All right, first thing guys, new sending unit, and reading some of your comments on my initial like kind of teaser post, a lot of you said, yeah, just check the resistance post to post, and it should be between like 10 and 70 ohms, and so we can do that first. So let's go all the way empty. All the way empty is 70 ohms, 73 ohms, and then go all the way full, 9.4. So pretty accurate description. Some of you guys are on it, and it's pretty awesome that you knew that. That is a test you can do on the car, post to post. You should have somewhere between 10 and 70 ohms of resistance on that float. So this video is for my Power Wagon buddies, and what we're doing is I'm gonna drop the fuel tank because I have some debris that I found in the fuel filter. It's getting plugged up in the carburetor. And at the same time, I'm dropping the tank because my gauge does not work. And so I wanna show you guys how to troubleshoot properly the fuel gauge with this video. As far as the fuel gauge goes, I've already done the troubleshooting on this, and I know that my problem is in the tank. So when I drop the tank, it will be twofold. One, to clean it out, and two is to fix the sending unit. But I wanna show you guys how to test this gauge and make sure it's functional before you would ever drop a fuel tank, especially on these older trucks that tend to be very rusty. As you guys know, bad grounds are very common on older vehicles like this. And so anytime you're doing any kind of electrical checks, you wanna make sure that you have a good ground on your meter. So my tool of choice has been my Power Probe. This is a Power Probe 4. The stuff that I'm gonna be showing you guys can be followed with a regular, cheap multimeter. My suggestion though is that you run, we're gonna be doing checks at the tank, that you run a long jumper wire to battery negative for all of your tests to make sure that you're getting accurate readings, because if we go to the frame or the body of the truck, we may not have a good ground, and then our voltage readings are gonna be off. So we definitely want to go to the battery for all of our tests. Okay, step one, turn the key on. Key's in the run position. We have no movement of the fuel gauge whatsoever. Ignore the ammeter, that has been bypassed. Fuel gauge not moving. I know I have gas in it. When I drove it to get the exhaust on, I put about 5 gallons of fuel in it. No reading on the gauge. All right, sending unit location. If you have a body lift on one of these, it sure makes it a lot easier. But there's the 2 wires that are going to the top of the tank. And it's going to be a little bit difficult to get this probe in here with the camera, so I'm going to use something that's going to help me both with the camera shot and also just to do checks on these wires as they sit. Let me show you the tool. So I have a few different ones. It's a piercing probe. I have a longer one and a shorter one. And the nice thing about this is it has a sort of bed of nails on the end of that. So you hook the wire and poke into it, and then you can adapt your alligator clip here or on the back side and get voltage readings. Of course, when you poke holes in wires, you should fix them when you're done. We don't want to leave holes and create problems down the road. So the stuff that I use is liquid tape. Okay, so we're going to do that when we're finished, but we're going to poke some small holes, take some measurements. First thing I'm going to do is I'll hook the blue one. And what you guys will do with the equipment you have, to each his own. You're gonna poke a hole in a wire, that's fine. Just make sure you seal it up when you're done. Of course, we can disconnect the wires and test them that way, but I wanna test them with them connected to the sending unit. That's my preferred method. The key is on right now, and I'm just gonna touch the tip. All right, 5 volts. So fixed at 5 right away, that's telling me I have an open circuit in this pump. We wanna have 5. If I were to disconnect this wire, this would be the sending unit wire. If I were to disconnect this wire, that's what we'd wanna see, is 5 volts coming down here. And that would tell you the integrity of your wiring from the front all the way up there at the gauge, down underneath the truck, down to the sending unit. That would tell you that you have no opens when you read a steady 5. That again is my signal. And then let's check the other wire, because a bad ground can be elevated and cause this too. So let's check the other wire. We change that up just a bit because I don't want to switch back and forth. We're going to stay on this sending unit wire where we're reading 5 volts. And what I'm going to do is I'm going to add a ground to this. Let me make sure I get this right with my tool because I don't use this way often. So that applies a ground when I flip a switch that way down. When I flip the switch up, it applies power. That's why this is a dangerous tool in the wrong hands. You can add power or ground to things when you should not be. But basically, we want to ground this circuit, and we only want to do it momentarily. You definitely want to have a partner when you're doing this because you can overheat the gauge. I'll describe that for you in a minute. I'm going to ground this circuit. That gauge should move toward full, okay? You ready? Did it? Where's it at? Tell me when it's full. Okay, good. Well, we have to show my cameraman daughter, or camera woman. May is helping me. This is for our Power Wagon group, May. So they haven't seen you before. She is 13 and she has helped me in other videos too. Go ahead, you can stop recording with that. We'll sync that up so everybody can see it. That is all I needed from you, sweetheart. Thank you so much. Yeah. Say hi to everyone. Hi. And bye. Bye. Thanks for helping. Yeah. All right, so we're not done. I moved my probe now to the ground wire. So this ground test, think about it. We have 5 volts coming in on the, we'll call it the signal wire, but it's really the sending unit wire. I can't see my probes in the way here. Let me move that, right? The blue wire looks blue. That's 5 volts coming in, goes through the resistor that's in the float, and then comes out and gets grounded by the wire that I'm on, this white wire. It looks white. You know, the wire colors change, but if this ground is open, we're gonna read 5 volts in this same location. Okay, loaded circuit, key is on, sending unit's powered up, and we're checking ground voltage. So we're doing a ground to ground voltage drop test. You see we're reading a full ground, 0.02 on the tip of that probe, which is on that wire. Remove the tool, got nothing, put the tool on it, 0.02. That's a loaded circuit test. If that was open, we would read 5. That is not the case. So really the final thing before you drop the tank is we want to make sure in this circumstance that those ends where it connects to the sending unit itself are making good contact. And really that's just going to involve maybe unplugging them, plugging them back in, wiggling it around a little bit. And when we do that, we can monitor the sending unit wire while we're doing that, while we're doing our wiggle test. So switching back. I'm back on the sending unit wire. I'm reading 5 volts. I can't tell if you guys can see that or not, but I'm gonna reach up and wiggle this. Okay, I can't show you me wiggling and the probe at the same time. I will show you the probe. So wiggle the ground one, back and forth. No change whatsoever. Wiggle the sending unit wire. No change there either. Now depending on your situation at this point, you could unplug those 2 connectors, do a resistance measurement on the float itself. You should have something there. You should have some continuity. And the other thing you could do is you could take those terminals off, try to clean them, put them back on, but our problem is absolutely right here, okay? For me, I gotta drop the tank anyway because I'm getting crap in my carburetor. So the tank's coming down, and then we'll show the final checks you can do on the sending unit when the tank is on the ground. But we've done enough to confirm, to say, hey, this tank definitely needs to come down. If you need to go buy fuel tank straps, go do it. Try to order them. Look how rusty the truck is. You know, use all of that as a guide to what you're gonna do, but this tank's gotta come down, and that's where I'm going next. Almost forgot, I want to talk real quickly about why you don't want to ground this type of gauge for too long when you're doing these kind of tests. The type of gauge that this is a bimetallic gauge. I got to give props to a guy. His name is Dan Svitko. These are the notes, Dan. These are the notes that I took when I was in your class in 1992.
I still have them. These things were like gold to me back then. But what we have is the gauge setup. You can see that we have battery voltage going to an ignition switch. And then from there, it's going to an instrument voltage regulator, right? It's a 5-volt output. So that then goes to the gauge. In our case, there's a bimetallic strip in the gauge. Coil is wrapped around that bimetallic. And then it comes down. This is our sending unit wire, right? It comes down to the sending unit. And then the amount of resistance here will dictate the amount of current flow coming from the voltage regulator through the gauge coil. And then it will also factor in heat. So the higher the current flow, the more we warp this bimetallic strip and the more it moves toward full, right? Or hot or cold. In this case, this is a temperature gauge example, but it's the same thing. So if the resistance is very low down here, then we have a lot of current flow, a lot of heat, warps to full. If we have a lot of resistance here, very little current flow, very little heat, bimetallic cools off, moves toward cold. The reason why you don't want to ground this type of gauge very long is there's always supposed to be some type of resistance here, and we're grounding it independent of any resistance, heating that up higher than it should be. And from what I've read, what I've heard, I've never damaged one doing this, but you can damage these bimetallic gauges whenever you ground this circuit for too long. So just be aware of that. If you're working by yourself, my suggestion would be that you, instead of grounding this wire fully, is that you take an incandescent test light, cannot be an LED test light, but take an incandescent test light, connect it to ground, and then touch on your sending unit wire, and that'll make this heat up enough to move it at least off of empty, and you'll see the gauge start to move just a little bit. It might not even reach quarter tank with the test light, but then you can leave that hooked up while you come up front to the truck and check your gauge. If you're working by yourself. If you're working with a partner, as we did, you can ground that. Just make sure you don't ground that for very long. I should also add that instead of dropping the tank, depending on your situation, you can lift the bed. That might be a little bit better of an option depending how rusty your tank straps are. In my case, I spent so much time lining up the bed and getting it right. I'm not touching the bed bolts. I could do that, but my tank straps are brand new, so it's not gonna be a problem me taking the tank down. That's the method I'm using. Brand new tank bolts, brand new tank straps. By the way, there's your ground for the tank sending unit. And a lot of people would maybe at this point just want to clean that. And of course that's a great idea if you don't know how to do voltage measurements. If this ground was bad in this location, that 5 volts that comes into the sending unit would wrap through the resistor, regardless of float position. It would come out onto this ground wire, and it would be sitting right here. That voltage would be sitting right here, and it'd be backing up, almost like pressure backup from a bad ground. And we had low voltage at the sending unit, so that's not our problem. I don't need to clean that ground. Okay, so I said, new straps. I'm gonna drop the tank. The problem is, when this was done, he must have done this when the bed was off of it, because I cannot access the nuts on the backside of those bolts. No way I can get to them, and they just spin. Yeah, there's no gaps there. Same with these guys right here. I just did one, it just spins. I can't get to the nut inside. Not a chance. Could possibly get to those ones because there's some gaps on the inside, like up in there, but I'm probably gonna lift the bed. And I guess a question for the community would be, what were these from the factory? Did they have studs that came down? I mean, because there's no way to get a wrench up in there to hold the nut on the other side. And like I said, I'm guessing he must have replaced these bolts when the bed was off. I was thinking, well, I could leave this one alone, take the strap off the top, loosen that, and then slide the whole tank back, but I'd still have to fight these guys, because this side over here, that is that's not a bolt. It's like a sleeve that goes into a slot, so I can't unbolt it there and pull it down. This one is a nut on the other side. I could do it with that one, and I was thinking, well, I could take the two straps off and then slide the tank back and then down, but there's no room. I'd have to take the shock off. Yeah, I don't want to do that, because that's a lot of movement. I'd have to slide the tank back to clear this. And so, yeah, so I'm just curious to see factory-wise, you know, what they used here and what you guys do when you have to drop the tank. I mean, shoot, I'm really not even sure, but I have the option to lift the bed, and I think that's what I'm gonna do. It doesn't make for easily draining the tank like I had hoped, but I really don't see any other option for me at this point. I'm gonna lift the bed. Love to hear your guys' thoughts. Hold up, this is Bo, my third boy. This is Jake, my oldest. And this is Caleb, my cameraman, editor. So this is the beauty of having sons right here. What you're watching right here, beauty of having sons.
Yeah, I drove 30 minutes just to move this.
Okay. You two in the back. We're gonna lift. Me and Caleb on the front.
Oh, this is ready? 1, 2, 3.
It'll be fun.
This
Easy. Go.
wait.
As much of a pain as that was definitely better than dropping the tank. Hey, sons. Yo,
What's up?
yo, look here, all three
Hang on, I'm
sons.
getting my Crocs back on.
Thank you, sons. I got all 4 of my kids in this video.
You got it. Where's May?
May was in the first part.
Oh.
She helped me with the sending unit test. And now I have access back here. So I have that pad sitting on a block of wood on the frame. I'm not back too far in that, you know, I'm still sitting on the frame in the back on this one bed rail. Same for the other side. Way in there. Block of wood on the other side. So we're not resting on the tires here. And I took my bumper off too, so we had room, you know, so I didn't mess anything up. Disconnected the wiring in the back. It was actually really easy to move the bed. That was definitely the way to go. Especially because all the bolts were free and this was moved around already, and yeah, this was definitely the way to go. All right, let's see what we got here. We put an inspection camera in here too. We can look at what's in this tank. I have an inspection camera. Maybe we'll do that. I mean, we could drain it too. But this rust came from somewhere. It's a plastic tank. I mean, it shouldn't have came from the tank. But this, like I said, this is a 9-year project. As far as the float goes, you know what I didn't consider is, like, did he have them backwards? You know, the sending unit wire and the ground, and then full would be empty, empty would be full. But I did put gas in it, so it's not empty or full, and we should have some reading if they were backwards. That's kind of my logic on that, so I'm not going to sweat that right now, but that is something to consider on a build. I have to remember that the signal wire for the sending unit was closest to the vent tube. Here, just RTV. Be careful with the float. There she is. A ground pin, right? It's a non-insulated piece, so it grounds the housing itself. And the sending unit wires this one, and that was the one closest to the vent tube. All right, I'm switching up here. It's getting dark. It's probably going to be hard to see. I'm switching up to my multimeter, and I'm using a nice thing about the Power Probe is I'm using the Power Probe ground. It has a ground connection, so I know my ground is good on my meter. So I'm using the Power Probe for a ground, just kind of keeping that thing away from the fuel. It has a battery in it and a light, and I don't know. I just don't want it there. I'm just going to do voltage measurements. At this point, Set that up so you guys can see. We're gonna hook the signal wire. I keep calling signal. Guys, I deal with computer controls all the time. You gotta forgive me. The sending unit wire, you call it a signal wire if you want. And then the end of my multimeter lead is gonna go there. That's just gonna allow us to view the voltage on that circuit rather than going up to the gauge to see if it's working. I can show you right here whether or not it's working. Again, twofold reason to do all of this. I need to get the fuel out of this. I'm not rebuilding my carburetor with what I saw in that fuel filter. So I just have all my wiring hooked up. You see we have 5 volts on that. And then as I move the float, this voltage should change. And you see there's no change whatsoever. So my problem is down here in this resistor assembly. Okay, we can do another voltage reading inside to show you that's 5.3 volts. I mean, we could have a problem up here. It is possible that the sending unit housing is an issue. So we'll do another voltage measurement inside. And there's some just bare connector there. We can measure it right at that location, or just right there works too. No problem here with poking a hole in a wire here. This is surrounded by fuel all the time anyway, and as you can see, there is a bare terminal already on that. Non-issue here, guys. This is a faulty float for sure. Okay, 5 volts in that location. The housing itself is the ground. So it actually grounds on the housing here, goes up the tube into the housing. The ground terminal here, the non-insulated one, is your ground for the housing, and then that gets externally grounded there. So a way that you can check the inside ground, again, some of you guys might want to use an ohm meter for this. I prefer the voltage measurements we're doing. It's just easier to see too. But a quick ground test for the housing. We tested the sending unit wire coming through, right? In that we have the same voltage here at the end. Okay, the through connector is fine. I hope that makes sense. That is insulated right there. So you have your 5 volts comes through from the gauge. It's insulated, then works its way down right on that wire to the float, to the resistor in there. So I'm testing, by testing here and having the same voltage I had outside on the sending unit wire, that confirms that that connection's fine. And then now I'm checking the ground itself, and it's just gonna be simply, we don't need this anymore. This would be something that should have been tested before this was put in. Now, when you are doing a project, you definitely would want to use an ohm meter. So I guess I can show you guys the ohm test here too. I probably should do that for you guys that wouldn't have a battery connected yet, wouldn't have an ignition, to turn the key on, none of that. You'd want to do some ohm meter testing. So yeah, we should do that. But the ground test is simply, again, loaded circuit. We got voltage coming in, just clipping anywhere on the housing itself. Anywhere on the housing. We'll make sure we have good connection. And let's change our range. It's an auto ranging scale, so that can be misleading. That auto ranged on us. Oh, my battery's dead. No, it's dying. Okay, change the battery in my meter. Make sure we're clear on what we're doing. I have a known good ground on my meter already, so we're doing ground to ground voltage drop testing again. And I'm showing you that I have low voltage inside here on the sending unit. I have some crap on here, so that's going to change like your readings. I can go in various locations. You see up here, if I squeeze tight, we have 3 millivolts, 1 millivolt. That is a good ground. There's nothing wrong with our ground. The other thing you might want to do is on the housing itself, because that's where it gets grounded. first. Make sure that you don't have like a ground connection problem up in there. Let me just look at this for a second. When we open this up, we'll see, yeah, it's going to ground to that housing, and then that's kind of, you know, welded to that tube. So it's really going to be this tube here. And you see we have some millivolt reading. If I squeeze that tight, move it around, we can drop that number down. Right, there's 0.1. That's a good ground, 0.01. There's nothing wrong with the ground. This is bad inside. I'll show you the resistance measurements, and then let's open that up and see if there's anything we can do in there other than ordering a new sending unit. I need a new sending unit. All right, using the inspection camera, it does have a mic on it, and not a great audio here, but I tried doing this last night, and I was really having some difficulty doing it because of reflection with the fuel. We'll do the best we can here. So I'm not seeing rust in the tank. I am seeing some discoloration in the plastic, and I went in. I don't know if you can see any of the scratch marks. I used like a screwdriver to see if there was a lot of debris in there. I can't really explain the discoloration parts, but it's not heavy, and I can't really scrape it off. The fuel looks good. There are some metallic pieces in there that I tried using a magnet to pull out, and I cannot. So I'm not totally sure where those came from. But nothing that is going to make me really want to drop this tank. I'm just going to change my fuel filter maybe a few times through the first couple of tankfuls and go from there. Also, the sock strainer itself looked pretty good when I pulled it out. So we're going to call that okay as far as tank inspection goes. I may regret that. Yeah, worst case scenario, I drop the tank at a later time. So bottom line, the tank looks good. I don't see a lot of rust in there. I see some little metal flakes, but there must be aluminum. I'm not sure where that would have come from. You know, nothing all over the sock either of the pickup inside. The sock strainer, the inlet of the sending unit, the fuel inlet, that looked good too. Just trying to think of where that could have come from. Fuel line itself, I mean, sitting for 9 years, moisture. Yeah, it's possible. The tank looks good. Final thing is we'll do the ohm meter checks for you guys and see if we can fix this thing or order a new part. I'll get some after, so it won't be final. Final thing for me tonight is the ohm meter checks for you guys. Okay, so the resistance measurements, you want to set your meter up on an ohm scale. And you want to check your meter first. Always check your meter. This is an auto ranging scale. Connect your leads together. Make sure you read 0 ohms on the lowest scale. Okay, so that's good. And then the first check that you can do on this sending unit is go to your sending unit wire, the insulated one. We want to check that. And so connect one lead to the pin right there. And then the other lead, you want to connect anywhere on the housing. Remember the grounds we checked on the truck, same way here. We don't want to have any reading whatsoever when you go between the sending unit wire and the housing. That checks the insulation in between. You can see I stayed on the mega ohm scale. That never moved, so that's good. And that tells you that that insulation is good. That's check 1 when you're bench testing these. The second one would be from the outside sending unit wire down to the where it connects to the float. In that location, this you want to have a 0 ohm reading, and what that's checking is the connection through the housing and the wire all the way down to the sending unit. You can see I'm reading a half an ohm of resistance. I could probably get that lower if that was cleaner. There's 0.4, 0.3. And when I touch these together, just as a baseline, this is just a cheap multimeter. Yeah, so you can see that same resistance measurement. Oh, that's even worse. 0.4. So just the connections themselves. I have some resistance in my cables is my point. 0.3 is good. I like that. Go back to this. Okay. That's my sending unit wire down to the housing. So we really did all the checks there. End to end, again, that should be 0 ohms. Watch your scales. Make sure we're making connection. I might even switch my leads around, but from my last one. Oh, I'm going to the ground. Wrong pin there, Danner. Sorry. Go to the sending unit wire. Okay, basically 0 ohms. All the way down to there, that's good. Your ground itself is pretty straightforward. That's going to be clipped to the ground on the outside, and then anywhere on the housing, and we want to have 0 ohms for that check as well. And why is that not reading? Am I having a lead issue here? Always check your meter when you're getting weird readings. Nope, we're good. Polarity is not important when you're using an ohm meter. This should be a 0 ohm reading here, and I'm getting some weird stuff here. Oh, look at that. So this is a problem too. That's why I was getting such wacky readings here. This pin is loose. Let's see if you can see right here. I'm turning that. That's why I'm getting such weird readings. Like, that shouldn't be doing that. And the more that I moved it, the worse it got. But to check the float, independent of that, all you would need to do is go back on your sending unit wire. The polarity isn't important. You probably see me switching my leads back and forth. And then go to the housing, which would be your ground. Right on the inside, we know that our connection's good up to here, so we're on the ground on the inside, and then move your float, and you can see nothing's changing. So I created that problem, which is that ground pin. That's not good, in that movement in that pin. That can be fixed, but our problem is in here. I hope that makes sense. I'm on the sending unit wire out here. We confirmed that it's good from there to there. And then I'm on the ground on the inside because my ground externally is giving me problems. If to answer really any questions, you can take this and go right to the float itself, right on the wire to the resistor inside, go to ground. The meter should go through the coil and run to ground. Here I should have continuity. I do not. Move your float up and down. No changes whatsoever. And it sounds like there is liquid in here. Yes, and it's leaking. Full of gas. So even if you fix the float, the resistor inside, you still have a barrel that's full of fuel. And that's going to mess up the float. It'll never work right. I need to order a new one. Might as well take this part further and see what else is inside of here. And guys, just so we're clear, this area now, we're out of my area of expertise. Like, I don't repair stuff like this. There's a lot of you guys that are on these truck forums and stuff that you probably repair these yourself. And, you know, I could probably send this to you and you fix it for me and send it back to me, which is awesome. So I just want to be clear, this is not my area right here now in doing stuff like this, but I do want to see the resistor. I want to show you guys what's inside of it. There's your resistor. I don't know that it was just never making contact. Right, the end of this right here, that button, that rides on this resistor internally. That should be insulated at the top. Yeah, I bet you, you know, really just cleaning that up, maybe bending this up a little bit so it makes better contact. Let's just try it. I know some of you guys are laughing at me now. Like, what's this guy doing? Okay. Meter. Resistance. This should change as I move this float arm. Oh, I can hear it touching now. It wasn't making that sound before. Again, polarity is not important. One end to each. Right, one to ground, one to the sending unit wire. Move your float. Still no resistance changes. So it's not going to be that. That's got to be a good ground on here too. So this has to be really clean because this is your ground. This area is your ground. So let's check that. Yeah, that's good. This can be checked too. I need a pin though. Connect to there. And then touch different points on this resistor. Just using the inside jaws of the clamp, and I have no continuity there at all. So my problem is like right in here where this comes through. Yeah. There should be that wire, which is a resistor. It should be contacting this pad. So it's good coming through, but I'm just using an extension here. You can see what I'm doing. Lead on, one test lead on the outside plug, and then the inside pad. Right, you see I have continuity there, but then when I touch the resistor right there, I have nothing. So that's never making contact with the pad. And I was looking to see if there's a broken piece, and usually you'll be able to see it, and I just don't. Time for a new sending unit. I'm not going to try to fix this. I'm sure these are available. Oh, I'm done. I'm not fixing it. Got a barrel full of, a float full of gas. I got a messed up resistor. I got a messed up pin right here. I'm not fixing this. I'm going to replace it. I hope you guys learned something from that. I am Captain Longwind. That's what my son calls me. I'm a teacher. I'm an auto tech. I've been teaching for 20 years, and now I do video teaching. And yeah, this was fun. I hope you guys learned something. Oh, but we're not done. Got to get a new one. We'll redo these checks.
Okay, I'm back, and I have my son behind the camera, thankfully, because that was really difficult to this point. Second thing is I got a little bit of a head cold. What are we calling it? COVID-22. Yeah, that's what I have. So I apologize for sounding a little nasally, but we got a new sending unit. So I want to show you a couple tests on that. And then I also want to show you what I'm working on the table. Really what brought me to this in moving the bed and all of this. Well, of course, the float wasn't working, but I was worried about debris in the fuel tank, and I am not any longer. That fuel tank looks pretty good. There is some stuff in there that little metal flakes that aren't gonna ever make it past the strainers or the fuel filter, and I'm not dropping the tank to clean it. I may regret that in that I have to pull the carburetor back apart at some point in time, but I don't really care. It's not a big deal. But I want to talk about what's on the table here for a minute. So I pulled the carb apart, and here's a shot of a little video shot of the debris that was inside of the carburetor. And you know, after seeing that, I really went back in the tank and looked closely. And I got to tell you that all the stuff you're seeing here is from fuel sitting in a carburetor for years. And this is what happens. You can see it in any gasoline powered, weed whacker, lawnmower, anything that you leave fuel in for a long period of time, you end up seeing this kind of crap in there. If you look at the screens right here, those are the inlets for the carburetor. They're right here. You'd have the big heavy screen here. And this inlet seat does not have a screen because it goes down over top of that, but this one does on this side, and there's a passage that runs between. Those screens were absolutely clean, so it wasn't coming from the tank. The screens being clean definitely gives me more confidence to button that up. I'm not taking that tank down right now. Pretty cool stuff though, rebuilding a carburetor. You can see the kit that we have and all the components that are involved, doing float adjustments and float level and float drop. And one of the things is when these floats were set up, they were really not set up properly. You can see actually the float and the way the level was, that it was angled. When these were set up, it was set up where it was, I think, lower in the front and higher in the back. And the procedures tell you to set the float, it should be parallel to the housing. And so I reconfigured it, set the float levels correctly, it's parallel. And then that was one. And then the other one's the float drop. Where you're doing measurements, you see your float drop measurement, and then your float level measurement was done with a drill bit, as you can see here. And all that was fun. Anyway, let's go back to the truck. Let me show you the new sending unit. We'll plug in the new numbers to help you guys in your troubleshooting of a gauge issue in the future. All right, first thing guys, new sending unit, and reading some of your comments on my initial kind of teaser post. A lot of you said, yeah, just check the resistance post to post, and it should be between like 10 and 70 ohms. And so we can do that first. So let's go all the way empty. All the way empty is 70 ohms, 73 ohms, and then go all the way full, 9.4. So pretty accurate description. Some of you guys are on it, and it's pretty awesome that you knew that. That is a test you can do on the car, post to post. You should have somewhere between 10 and 70 ohms of resistance on that float. As far as the tests that we did for the ground, you remember we having some grounding issues. The ground pin is here and it's attached to the housing. Anywhere inside that you connect to, it's going to be 0 ohms. So I'm going from the ground, and this is how we found that loose ground pin inside, right? We had enough information to say bad sending unit, but I said further checks should be done inside. Using the ohm meter was the key to finding that bad ground. But you can see anywhere I go, so that's 0 there. If I go up here, it's going to be 0. If I go to the arm of the float even, it's going to be 0, right? That is your grounding point, okay? And then, of course, your feed wire or your sending unit wire, we already talked about that, but you want to make sure, I guess one last one would be sending unit wire to ground. We don't want to have, well, let me think about that. Yeah, we can't really do that test to check for a short to ground through the housing. Yeah, so I kind of messed up on that, realizing circuit design here, I can't isolate the ground. So to check this insulation area from here to here, what I was telling you guys is inaccurate, because whether I go here or to the ground stud, it makes no difference. I'm going to be reading through the resistor of the sending unit. So again, to check that insulation area for the sending unit wire, you'd have to disconnect it from either this end or this end if possible to check it, and that's really not going to be easy to do. You'd have to really cut the wire in this case and fix it. So that would essentially only be for you guys that are using an old sending unit and you want to make sure that that insulation is good. You'd have to isolate the sending unit wire in some way, whether it be cut the wire here, fix it when you're done, detach it here if there's a way to do that, or up here if there's a way to do that, to check that insulation, and that's really not going to be a great test. But the resistance check is good between the two. The ohm check is good between the ground and anywhere in here. Let's go in the car. Let me show you the voltage measurement now. Turn the key on. Hopefully I'm being clear. Our ground test that we did, I said was a loaded circuit test, and that's the way you want to do it. Well, when you have an open inside here, it's never loading the ground. So our 0 volt reading we had right here did tell us enough. Having 5 volts here and 0 here tells you enough to go inside, drop the tank, pull the bed for sure. But with this being open, we're not really loading this ground. So that 0 volt reading we had was not accurate in that checking that ground on the frame was never under load. So that's the downside of a voltage drop test. The ohm meter would really be the better measurement with this fault inside. However, again, what we did was enough to say go inside, but I'm gonna redo this check on the ground now that we have a complete circuit. But let me show you voltage first. Why is that bouncing around? I need to answer a question for myself here real quick. So I knew these were pulsed, but didn't know that they're only pulsed when there's a load. I'll be showing you some scope stuff here in a second. Huh, that's kind of cool. Open signal is a steady 5. With a load, it's pulsed. So let me show you that. Let's make it an open. Yeah, steady 5. Okay. So there's a variable here. Are you seeing my scope too? You were? Okay. I was not aware of that. I knew these were pulsed, and I wasn't totally sure in operation of that IVR, that instrument voltage regulator. You can see a steady 5 with an open circuit. And when I plug it in, now that we have a load here, you know, this is on the signal. Hang on, I need to check something here for myself. This is with the tank empty, and then this is with the tank full. You see the drop in the signal. Scope full. Scope empty. I knew these were pulsed, and you see on my multimeter how we have a pulsing voltage, and so that's really going to make voltage measurements on this design a little bit hard to interpret, because you see my scope, the yellow line on there is 5 volts, which we saw when it was unplugged, and now that it's plugged in, we're getting voltage spikes. Let's get the highest ones just to get a measurement for you. The peaks of those, that's like 9.4 volts at the peak. And then in the empty or in the full position, those are down to 4.6 volts, 4.5 volts. That's interesting. Just operation of the circuit's different than what I expected. And the float arm just moved on me. That's why the level changed. But really anywhere from 0 to 9 volt pulsing. And you guys are just gonna have a multimeter. That's what you're gonna see. I was surprised to see the steady voltage signal. I have some digital photos here of the IVR up inside of the dash. You guys can tell me, because this is a little bit older than what I'm used to. And I remember these IVRs just simply being able to be unplugged. I don't remember seeing a big diode, what looks like a diode or capacitor on the side of it. And this one looks soldered, and I'm not completely sure. Be interesting to hear your guys' comments on this IVR, if this was modified at all. But that would be a variable with these older cars, is how do you know what you're working on has some type of modified IVR already in it? You don't know that. Pulsing signals, that's what you're gonna see. No pulsing signal with no current flow, with an open circuit. Again, no current flow, 5 volts, okay? Didn't expect to see that. All right, now that we know our ground is being used and loaded, our ground test that can be done. So if you're on the car and you're looking at your meter and you're seeing a signal that's moving like that, then your gauge should be working. In fact, before we do the ground, let's go inside and have a look. You're reading about a half tank right now, right? So I'm gonna make this go all the way full, and hopefully we'll see that gauge rise to full. And if it doesn't, I'm I'm gonna be concerned about the calibration here. I wanna see all the way full. So that's all the way full, and we may never see it that high. I just have it maxed out on the sending unit. It's a little bit past, I'm okay with that. Going empty now. That should be all the way empty. I definitely ScannerDannered this one, Caleb. I tried to make it simple for the community.
You can't do that.
I know, I tried. I tried. I really did. And I just hope that when the people watch this, keep your eye on that. That they'll understand like the whole picture, that they'll be able to plug in the tools that they have. Really, that was the intent. You know me, I definitely, look, I got a lab scope on this. I mean, you know, these guys are gonna be like, who is this freaking joker? Yeah, all right, I like that. All right, to rehash, this is on the truck, and you get some way to adapt to the sending unit wire, which is kind of hard to see, probably camera angle for Caleb. Let me slide this. Okay, so the sending unit wire, and then if you have no voltage here with the key on, you're going toward the front. You're going toward the front. If you have voltage there, that's a good thing. Disconnect the wire, ground it, make sure the gauge moves. Okay, remember, don't do that very long. It's a thermostatic gauge. And then the other thing too is if you see a steady 5, at least on mine, and I'm not convinced that they're all gonna be like this, but if you see a steady 5, before you make the call and going inside, check your ground wire. Make sure that ground is good. So let me do that. Going on my ground wire. And this is a loaded circuit now, voltage drop test. I'm reading 34 millivolts on that ground. If that ground is bad, what we're gonna see is the source, which is 5, okay? So if you see 5 in that location or anything higher than that, I mean, even that voltage to me is high for a circuit like this. 33, 40 millivolts. It's fluctuating because the voltage isn't the same, it's being surged. If that's a sensor ground, for sensor grounds, we always say 100 millivolts or less, so I guess that's not high. I'm good with that number. Let me change the range to give you a better perspective. Like, that's what we're talking about voltage wise. It's 30 millivolts on that ground. I'm good with that. I'm good with that. Anything more, in my opinion, than 0.1 on that circuit, you want to clean that ground up. As that ground gets corroded, that voltage is going to rise higher and higher and higher and higher. Eventually, if it's completely open, you'll read 5 volts on that circuit. So rather than me unbolting the ground to show you that, I'm going to simulate the open. I'm going to unplug my ground from here. I can't measure here because that is my ground that's open, but it's not being loaded. So that's not a valid test. As you can see, I'm reading 0 volts. That circuit needs to be loaded, okay? So I need to go on the pin to show you this. I'm gonna read 5 volts on this pin. Loaded circuit voltage drop test. And this proves again that the tests that we did were accurate to say go inside, because if that ground was bad externally, we would have read exactly that. 5 volts, which is the same as the source going in, which is 5. That's the ground pin. This is the sensor wire, signal wire, sending unit wire, feeding in, going to the float, going through the resistor, no voltage drop because there is no current flow with the open ground. And so it doesn't matter that it goes through all that resistance, the pressure stays high and you'll read 5 on that ground. And that's your measurements. If you read 5 on the signal and 5 on the ground, you have a ground problem. Don't drop the tank. If you read 5 on the signal and 0 on the ground, you're dropping the tank. Make sure when you go inside that the ground pin isn't messed up inside. There's some measurements you can do externally to check that internal ground, but either way, you're going inside to fix it. Tank's gotta come down or the bed's gotta be moved if you see 5 and 0. All right, so I know that some of that may be a little bit much, and I know for my Dodge truck enthusiast community, a lot of you guys, you don't do this at all and you need simple tests. I did provide some simple tests in here for you if you can look through the more complicated stuff. For some of you guys, You'll appreciate the extra electrical operation of this system so you can truly understand what it's doing. But we appreciate you guys being here. Look forward to your comments, especially from my Power Wagon community, Dodge truck community, my tin grill guys. I look forward to your comments on this one, and we thank you, and we'll see you next time.